we go. Yep or Dan?
On the last one,
Yep.
how do you, with the negative 2x left
Uh-huh.
I don't get how it goes from
How come? Okay, so good question. Think, rather than look at the fractional ones, let's look at a little easier one like a whole number power. When I anti-differentiate this, the raising by a 1 power, that's not a big deal. The thing is this, though, there's got to be some constant in here because right now this doesn't check. If I took the derivative on this, wouldn't that be 6x to the 5th, not x to the 5th? And so when you anti-differentiate, you say, well, it must have had something in here to cancel out the 6 I would expect, and that's done by division. So anytime you take an antiderivative of any power, it's raise it by 1, divide by that new power so as to cancel that n plus 1 that you get when I took a derivative. You with me? So when I take the antiderivative of x to the negative 1/2, if I raise it by 1, I have to divide by the half that I should have or need to cancel out front. When it's a fraction, though, better than writing it as over 1/2, we typically write it as times 3. So is that? Oh, I feel like I said that very well. Okay. All right. These are out of order. So let me fix that, and then we'll go. Area under the curve. Tomorrow we'll talk about area under the curve. It would be very logical for you to say area under the curve. Who cares? Yeah, he's trying to play make up reference point. Okay. And there is a point. Why would you want to find area under the curve? Well, gosh, it actually, got to get this past tonight. Why you would want area under the curve actually has tons of meaning. It's half of all calculus, really. And we'll talk about applications tomorrow. Today should go pretty well. Tomorrow we'll go a little deeper. So check this out. You're going to estimate area under curve today. Eventually, with calculus, you can find the exact area under a curve. There are a couple different methods, but usually it's about rectangles. Right now, this seems like a lot of words, so let me explain with a picture. Like I said, there's so many reasons you would want area under the curve, but tomorrow we'll talk about that. Today, just basics. If you were to estimate the area under the square root of x on 0 to 8 using 4 right-hand rectangles, I'm visual, and so I'm going to make you draw this for a while. You might say, I'm not visual, I don't need it. Well, I don't care. I'm visual, so you're doing it, all right? So when you graph this, please stretch it wide. When I say draw the curve, draw it wide. Even if it's, some like exponential or parabola where it really should be super steep, I still want you to draw it really wide. You'll see why in a second, okay? Now, if I look at the square root function, it looks like this from 0 to 8. Oui? All right. And it continues on forever. 4, 2, 3, 6. Okay? Now, our goal is to really say, what's this area? It's not geometric, it's kind of got a curve to it, but it's not circular, so that makes it hard to find exactly. We could use a figure that area goes really well on like rectangles, so that's what we're going to do. It says to use 4, don't worry about right hand right now, but it says estimate the area under the curve using 4 rectangles. Well, if I divide this total region up into 4 equal parts, then each base, or delta x, would come from the total width of the region, which is 8 minus 0, or 8y, and we're going to divide it into 4 equal parts, so each base will be 2. Now, I know that you didn't need to show all that. You could have easily done that mentally, but the problems won't always be so obvious in terms of base, and so I'm showing you where the calculations are coming from. You with me? That then is going to be, these are my 4 equal subdivisions. I'm going to use that as a base or 4 bases of rectangles. Now, here's where it says the method. There are a couple different rectangle methods. There's right hand, left hand, midpoint, upper, lower. It's actually, you could see actually probably 7 different names to this, but they're really only 3 different methods. If they say right hand, then in each subinterval from 0 to 2, you're going to go to the right edge of the interval, and for the height, you're going to go up at that point on the right edge until you get to the curve, and then draw over for your rectangle. And I'm going to use that rectangle to estimate the area under that curve. Now, is that rectangle a perfect estimate? No, that rectangle definitely has more area than I want. Yeah? And that's okay. We'll talk about getting more accuracy later, but just know that it's an estimation, so it's not going to be right on. You use the right hand edge to draw your height out. Now the next region is from 2 to 4. You go to the right edge, 4, put your pencil there, go up to the curve, and go over to make or complete your rectangle there. Rectangle 2 will be that area. Rectangle 3 will be to go to the right edge from 4 to 6, go up to the curve, draw over, and that's rectangle 3. And then the 4th rectangle will be to go to the right edge 8, go over until you get back to x equals 6, and draw down. You've got your 4 rectangles. Altogether then, every one of our 4 rectangles is above the area of the curve, so we're going to be overestimating. You follow? Okay. Now making the calculations. The area is 4 rectangles. Using the old formula substitute evaluate that you learned way back in Mr. Carlson's class. Or my class? No, I didn't have any of you. I don't think I had any of you in pre-algebra. All right, we have 4 rectangles. Now, if each of these bases is 2, then that's the easy part. Okay? The height is where you need to do a little bit of communicating to the person reading this. You don't just start throwing numbers at them. You start saying, hey, this is how I find my height. The first height, this is height 1. Height 1 came from using the right-hand side, and the right-hand side means the function at 2. The bases come from delta x's, the heights come from the function at different x's along the curve. So what's height 2? F at? Height 2 is right here, it's F at 4. Height 3 is F at 6, and the last was F at 8. Okay? Now because they all have a 2 in common, let's just factor that 2 out and focus on, there's a greatest common factor, and focus on just the functions. F at 2, well, that goes to what the function is. Now we're ready to go function specific. In this case, the function is the square root of x. So F at 2 is the square root of 2. F at 4 is the square root of 4, which, let me say that's 2. F at 6 is the square root of 6, and F at 8 is the square root of 8. Therefore, our area estimates, feel free to bust out the calculator, to 3 decimals is 3 17.384, yeah? Okay. You might also write in your notes, this is an overestimate. And this is an overestimate. You could, the common sensey kind of thing is to say it's an overestimate because what? Why is that an overestimate? Because the rectangles are bigger, yeah. Because the rectangles are bigger. Now, just to plant a seed, though, we're going to start to say this in a more calculus-y way. Why are the rectangles bigger? Well, because the right-hand side is actually the greatest function value over the whole interval, and it's the greatest function value because this is constantly increasing, right? That's why the right-hand side is so big, because this is an increasing function. And so you would also say, and later on in the AP test, you would say, we used right-hand rectangles on an increasing function. If it's an increasing function, the right-hand side will be the greatest possible value of the function, and we'll get an overestimate. You with me so far? Okay. Let's try a different method then. Right hand seemed to overestimate. Let's try left hand rectangles. If I did a quick sketch again, from 0 to 8, same curve, same region, same number of rectangles. So the delta x, or the base of each rectangle, is still going to be 2. What'll change this time is where we draw our height, or our rectangle estimates. If it's left-hand rectangles, then in the first subinterval, from 0 to 2, we use the left edge at which to draw our height. Now this is kooky because the left edge is actually 0. So our first rectangle is actually going to be no area. We're using the left-hand side for our rectangle. From 2 to 4, we use the left-hand side. Now when I say left-hand side, I'm going to go to the left edge, which is at 2, and I go up to the curve until I get the height of my rectangle. Now, this time, that's the left edge of the rectangle. I'm looking at this rectangle, so when I go to draw my other side, it's actually going to draw to the right because we drew our height at the left edge. So from 4 to 6, we're going to go to the left number, 4, go up to the curve, and then go over. And then last but not least, from 6 to 8, we go to the left edge or left end point, go up to the curve, and then go over. Now in this case, left-hand rectangles are definitely under the curve, and so this will not be an overestimate, but an underestimate, all right? We are going to still say our area is 4 rectangles. And each base is still 2, for the exact same reason. 8y divided into 4 rectangles is 2y each. So each one will be 2. Now, as we go, though, we're going to communicate where we're drawing our height at. Height 1 is the function at 0. The first region is from 0 to 2, and 0 is the left endpoint. So the first height is f at 0. The next region is from 2 to 4. We draw at the left endpoint. So this height, second height is f at 2. The third region is from 4 to 6. We're using the left endpoint, so we're drawing, for height 3 is f at 4. And the last is from 6 to 8. We're using the left edge because it's left, and so it's f at 6. Therefore, our calculation is, we could take a 2 out because there's a greatest common factor, and f at 0, actually square root of 0 plus square root of 2 plus square root of 4 plus square root of 6. And our calculator is something like 27. I'm getting 11.277274. Do you agree? Okay, this is an underestimate. If you have an increasing function, the left side will be the least of the y values, so it will be below this curve, and you'll get an underestimate. So couldn't you also say the true area then would be between the two answers, between the overestimate and the underestimate? It's got to be, I know the true area under the curve should be greater than 11.2727, but less than our first answer, or whatever it was, 17.384. Okay, boom. What's a way we can improve the accuracy of the area under the curve? We're getting all this here, this really represents error. Okay, that's that difference between the true area and our rectangles, that's our area. So how can we get less error? More rectangles, that's exactly right, more rectangles. If we did 8 rectangles, or infinitely many rectangles, by taking a limit, we could get perfect error, and we will. But for now, let's go with 4. Last but not least, using 4 rectangles, we're going to go midpoint. Now this is midpoint x. Draw yourself a picture, 0 to 8, and you might actually show all 8 marks. You'll need it. Okay. So the first region from 0 to 2, the midpoint, what's the midpoint between 0 to 2? 1. We're going to actually use then f at 1 to draw a height. So you go to 1, go up to the curve, and when I go to draw the opposite side of the rectangle, it's actually going to go across from 0 all the way to 2. Now you can see this will be better because you're getting a little overestimate and a little underestimate, and so you'll get a little more accuracy with midpoint on this kind of curve. You tracking? The next region is from 2 to 4. Where's the midpoint? 3. Okay, so you go to 3, go up to the curve, and at 3, that function value is going to be your height all the way across the rectangle from 2 all the way over to 4. That's rectangle 2. The next region is from 4 to 6. The midpoint is 5. Go to an x of 5, go up to the curve, and at that height, draw across from 4 to 6 for your third rectangle, and the last one is obviously at 7. Go up to 7, go across, and you're looking at that. And now again, this will be a best estimate because it has over and underestimating error. It'll be somewhere in between. It won't be perfect, but it'll be doggone close. All right, so the area is 4 rectangles. And the base of each is 2. What is height 1? F at 1. Then F at 3. Then F at 5. And F at 7. Okay. We can factor out a 2 because they all have a common base of a rectangle of 2. and just say the inside, the heights would be the square root of 1 plus the square root of 3 plus the square root of 5 plus the square root of 7. You're not always going to be using square root. That's just for this example, is the square root function. That f could be different for different problems, and it will be different for different problems. So don't think this always has square root in it. It doesn't. What do you get for an estimate? $16, did you say, or 15? 15.23? 22? 228? Does that kind of answer make sense? Right. Yeah, it's in the middle of those two over and under estimates. It's closer to the middle of that point. That's making sense. How good is this going? Are you doing okay so far? Can I throw a little challenge at you then? Let's do. Okay. This, you will sometimes see summation notation. Because you're going to involve repeated addition, you often use summation notation. It takes a while for this to get nailed, so just stick with me. We're gradually going to get better and better, all right? The idea is it's the sum of many delta x's times f at different x's. So you'll often see that area under the curve is represented by what's called a Riemann sum, just a fancy word, a fancy name for area by adding rectangles. Okay? In this problem, the delta x was always 2, yeah? And so you could go a little more specific there. You could also get a little more specific in terms of the rectangles. Now, in this case, I represents the number of rectangles. How many rectangles were used? 4. So as far as the starting index, we started with the first rectangle and ended at the 4th rectangle. We would have f at xi really just means the first height, the second height, the third height, the fourth. Bases are all the same, so I didn't know how those go. You with me? You could get a little more specific in this case and even say something like this, 2 square root of xi, because in this problem the function was the square root. And we'll gradually play with that. That is actually the same for all 3 rectangles. Then the what x, that's a little more complicated. All right, but just laying the ground. You with me so far? Okay. All right. Am I in the right place in my notes? Missing a piece. Sorry. All right. So this is just vocabulary. This will not be a huge deal. Okay. If it said estimate the area using 4 lower rectangles, I don't know if this will be necessary to do a ton of new work, because whether you know it or not, we already actually did this problem because it's going to be similar to something we already did. Lower rectangles means in each sub-interval, use the lowest point on the curve to draw for your height. Now, in this first subinterval from 0 to 2, here's the curve. What's the lowest possible point in that subinterval? Yeah. F at 0 is the lowest. All right. In the next region, from 2 to 4, here's the curve from 2 to 4. what's the lowest, f at 0 is going to be height 1. In the next region, what's the lowest possible value on the curve? F at 2. So if you were to draw your rectangles here, it would be find the lowest point of your curve and draw over for the region. Height 2 is f at 2. In region 3, which is from 4 to 6, the lowest possible curve is at 4. And in region 4, so your rectangle would be using 4 for the height over the entire region. And in the fourth rectangle, the lowest possible point of the curve is f at 6, so we use that for our rectangle. Well, what does that make it just like in this case? Left, right, midpoint. Okay. So because of that, this is just like left in this case. Let me do a little doodle over here just so you understand how they could not be the same. Imagine if a curve looked like this. Okay, 1 to 2. If I did left hand, then where would my first height be? Two left-hand rectangles. Where would my first height be? From 0 to 1, I would draw height 1 at, maybe I'm going too fast. Okay, if I was using two left-hand rectangles, from 0 to 1, I would use the left-hand endpoint, so my first height would be f at 0. Okay? And then from 1 to 2, if I use the left-hand endpoint, my second height would be f at 1. Okay? That would be left-hand. What if I used lower? In my first region, where would I draw my height at if I were doing lower rectangles? Then I'd use 1. And so you can see they'd be different. And then in the second region, where would I draw my height at? 1. So they're not always the same. It's just that this is increasing where left hand and lower came out to be the same. But you can see in the cases that wouldn't always be the same. All right. If I use 4 upper rectangles, then that means use the highest y value in each subinterval. When I use lower, what kind of estimate am I guaranteed to get? Over or under? Under. If I use upper, I'm guaranteed to get an overestimate, unless, of course, it's a constant function, which is like. All right. I think you get actually. Yeah, that's good. In this case, it would be upper would be just like right. Do you agree? Okay, let's go to the table. Sometimes you don't have a function that's given. Sometimes you just have a table. And you need to communicate your thinking in addition to getting the answer. So, say this actually is closest to what you get in real life. If I, for example, asked your speed at different points as you drove, then I could estimate how far you drove, how far you went by collecting data like this table. Estimate the area of the curve using 6 right-hand rectangles equal subdivisions. Now, eventually, with enough practice, you're not going to need a picture here, but I am going to draw a picture just because I believe it'll help. Looks like 3, 6, 9, 12, 15, and 18. And my y values look like they go up to about 8. Okay. Plot each point, and again, it doesn't have to be beautiful, but 0, 5, 3, 3, 7, 6, 9, 3, 5, 14, 0, 18, 3. Okay, now I have no idea what it's doing in between all those points. It could be kind of connect the dotty, but who's to say? It could be doing some craziness just within 3 units. It could be going up and down and hitting several maxes and mins. Who's to say? So never read too much into the table. And it's definitely not a connect the dot problem. All right. Now if I'm going to get the area into this curve using 6 right-hand rectangles of equal subdivisions, you have that. Should I give you another minute, or are we good to go? I'm going to start to do a little bit of cutting corners. Not too much. We're going to add 6 base times heights because we're finding areas of rectangles. Very cool? All the bases are the same. And because all the bases are the same, rather than call them base 1, base 2, base height, I'm just going to call it base and factor out a common base. The heights will be from the function itself. Now let's start to get into details. If I use right-hand rectangles, then look here. If in this first subinterval it goes from 0 to 3, then what's my right-hand height going to be? F at 0 or F at 3? F at 3. So my first height is F at 3. That's the right hand of the 0 to 3 interval. My next height is F at, well, the interval's from 3 to 6. If I use the right endpoint, then it's F at 6. My next height, height 3, is F at 9. Height 4 is F at 12. Height 5 is F at 15. And my last height is F at 18. Count to make sure you have answered the question. 6 rectangles, I should have 6 heights. 1, 2, 3, 4, 5, 6. Goes through there. Okay. The base. The base, or the distance along the x-axis, in this case, the base is 3. Now that I've communicated to the person, hey, these are where the numbers are coming from, now I can go to my table, and not before. This needs to be done before you go to your table. Now go to your table. Starting at 3 and going up, my heights will be 7, 4, 3, 8, 0, 3. Yeah? 7 plus 4 plus 3 plus 8 plus 0 plus 3. I'm using 6 of the 7 values. I'm not using the first one because that's a left-hand edge. After that, it's arithmetic. What's the total in there? Don't you even think about touching your calculator, you lose it. 11, 14, 22, 25? I agree. So the total area under the curve is, at least our estimate is, 75. Okay? Do you reckon that's an overestimate or an underestimate, or you can't say? Overestimate. Why do you say it's an overestimate? Because it's right. Okay. Now it's right is only an overestimate if the function is always increasing. Is the function always increasing?
No.
No. So we can't really say, I don't really know what's going on here, because it's increasing and decreasing. So you wouldn't be asked, is this an over or underestimate? You could, nobody could say. Okay? Try this one on your own, please. Estimate the area under F on 0 to 18 using 2 left-hand rectangles. 2, not 6, 2. You don't need to regraph it right here. Right. What's your base for each? 9. You could definitely factor out. In this case, it's not too much writing if I don't factor it out. But let's say I factor out my base, and that's 9. Cool. Okay. The heights need to be communicated where you're drawing them. Your first subinterval is from 0 to 9, yeah? If I'm using left-hand rectangles, do I use f at 0 or f at 9? F at 0. So height 1 should be f at 0. My next region is from 9 to 18. If I use the left edge, then I use f at 9. Now go to your table. 9 times f at 0, which was 5, plus f at 9, which was 3. What's your estimate? 72. Okay, good. All right. Let's go to just a little bit of vocabulary, but it's not really a big difference, right? Another word sometimes for lower is inscribed. Inscribed means within, or barely touching at the innermost point. And so you will sometimes see books use inscribed rather than lower, but it's the same idea. So if we were to estimate the area under the curve from 0 to 18, don't assume that they always use the whole region. Sometimes they'll actually only ask you for the area only from 0 to 6, so read carefully, but in this case they are saying the whole region, using 6 inscribed rectangles. Let's go here. I'm going to start by communicating. I'm using 6 rectangles. Please don't bypass that step. Well, there are a lot of methods. You can use trapezoids. You can use Simpson's rule. Okay, so don't think that first step is worthless. It communicates a lot to somebody that's seen all the methods. That tells the person you're using 6 rectangles rather than one of the other estimation methods, and there are at least 3. All right, so don't bypass that step. Then communicate to the person. In the next step, you're communicating to the person if there are equal subintervals. If a b is factored out, then all subintervals are equal. That also is important to show because you don't always do equal subintervals. Sometimes the first rectangle is 5 wide, the next rectangle is 3 wide, the next rectangle is 1 wide. It's not always equal bases, so please, that needs to be communicated. In the height, this is how you're going to communicate to the person where you found your heights rather than just go to the table and make them figure it out. Height 1. All right, now, height 1 is the region from 0 to 3, and I'm using the lowest possible value I can. And so for height 1, I'm going to use f at 0, because that's the lower of the two choices. Height 2 is in the next subinterval from 3 to 6. I choose the lowest value, so I choose f at 6, okay? Because that's the lower value in that region. The next region is from 6 to 9. I choose the lower value, so f at 6 or f at 9. F at 9. The next subinterval is from 9 to 12. Choose the lowest value of the two, so f at 9 again. From 12 to 15, I choose the lowest value, so f at which one? 15. And the last, from 0 to 3, I choose the lowest y value, not the lowest x value, obviously, the lowest y value, so f at 15 again. You track it? Okay. What's the base of each rectangle? 3. And then go to the table and report values. F at 0 is 5. F at 6, 4. F at 9.
Good morning, Denver Jaguars. Please rise for the Pledge of
Take
Allegiance.
the time though.
Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Let's finish this. We're not going to turn in your homework today, so don't worry about it.
All students, this Wednesday during 7th hour, there will be a girls swimming and diving interest meeting in the auditorium. Both new and returning athletes, please come and learn more about the program and begin planning for the season. Today, Scouts ordering the following colleges are here to visit with Mark Students. College of
You got
Worcester,
45. How about you?
University of Bloomington, Chapman University, Boston College.
You might try the last one on your own, see if you get the idea.
Tomorrow, 6 outstanding colleges will be here, such as the University College of Dublin, Boston University, College of St. Benedict and St. John, Campbell University, St. Lawrence University, and Gettysburg College. Show your interest and meet the college representatives to read your essay. This is a very important step in getting into your college of choice. Girls Metric is now collecting money for t-shirts. Please leave the $5 fee with your name in counseling. The deadline is October 5th. Please turn in your Get to Know You form if you haven't already. Senior high students, 11th graders will be taking a PSAT test on the morning of October 10th. To prepare for the test, you need to pre-bubble your answer sheet. Pre-bubbling is scheduled for the cafeteria on Wednesday, October 3rd during 7th hour for students with last names A through K, and Thursday, October 4th during 7th hour for students with last names L through Z. Bring a number 2 pencil for pre-bubbling. Devlin Jag, your Devlin cross-country runners had an awesome weekend in Estes Park. Your girls varsity team won the whole meet, led by first place finish by sophomore Taylor Airbig, who was followed closely second by freshman Eliana Thompson. Wish our runners luck as they conquer the path of athleticism invited this week. All your announcements, have a great day.
How are we doing on this? You good? What's the base of each if you divided 18 into 3 equal parts? 6. The base of each should be 6. If I use circumscribed, height 1 then is the biggest possible value from 0 to 6. So you're going to now look from 0 to 6, and what's the biggest possible height in that region? F at 3. So height 1 would be F at 3. The second height is the biggest possible value from 6 to 12, which is F at 12. And the last would be the biggest possible value from 12 to 18, which is F at 12 again. You would then go to the table and report those and calculate it. Anybody have an answer for that? Shout it out. You don't shout it out, you speak. Fine, you are recording. Boo. All right. Boo. I boo you. You're the word. Okay. Good job not speaking. What are we guys doing? Oh, a basket. Nothing's due today. Tomorrow, we'll have time to go over questions. So 36 and 37 should be Friday, right? All right.